Hi viewers, welcome to LMS Solution. Today we are going to see about grid connected PV system with 5-level multi-level inverter. So this is a simulation model we developed for the grid connected PV system with 5-level multi-level inverter. Here you see that this system having the 5-level multi-level inverter. This receive the DC input and it will be converted in AC, and the AC will be having the 5-level, and also the PV power is converted into AC form with the form of two-stage conversion. First, here we are using the boost converter in the first stage, and second stage we are using the 5-level multi-level inverter. The boost converter is going to be operate along with the P&O MPPT to extract the maximum power from the PV, and this multi-level inverter, 5-level inverter, it is going to be convert DC to AC by means of voltage and current control. Voltage control, here we are using PA controller. For current control we are using PR control. First here I am going to explain about PV system. PV system having the 6 panel in series. The single panel generating around 349.59, that means 350 watts. The single panel voltage is 43 volt and current is 8.13 amps. Totally it can generate around 2000 watts at 1000 watts per meter square. That means it generating around 2.09, that means 2.1 kilowatt. For 500 it will be generated around 1.1 kilowatt, and then for 100 watts per meter square it generating around 196 watts. So this is a graph of IV and PV characteristics of the consider PV array. We need to extract this maximum power from this PV arrays. For that we are going to use P&O MPPT, and also we need to boost the voltage, because here you see that the voltage level is around 258 volt. So we are going to connect this PV system to the AC, single phase AC. So here we are using a 230 volt AC system with the 50 hertz. Here we are mentioning 325 is the peak voltage. So 325 means it is 230 volt RMS. In order to connect this system to 230 volt RMS, so the DC link voltage, so this DC link voltage should be maintained around 400. Then PV voltage is around only 258 volt. We must boost the voltage from 258 to 400 volt. For that, here we are using boost converter. So this is a boost converter. So this boost converter will be boost the voltage from 258 to 400, and also this boost converter along with P&O MPPT will extract the maximum power from the PV array. Why we need to use this P&O MPPT? Here already I explained that the system having non-linear characteristics. Here you see that the graph is non-linear, is not linear, and also the peak point will be very according with the irradiation condition. When irradiation change or temperature change, we need to extract the maximum power. Then only we can tap the maximum power from the PV, and then we can send to that grid system. For that, we can take the maximum power from the PV array by means of the boost converter and the P&O MPPT. Here we are using P&O MPPT. It receive two inputs, PV voltage and current, and it going to be processed via this P&O MPPT, and it provide reference voltage. Inside the P&O MPPT, here we receiving that voltage and current, and here we are fixing the reference voltage, minimum voltage, that means maximum reference voltage, minimum reference voltage, the reference voltage initial and increment decrement voltage, and then here we are fixing the previous instant voltage power and reference voltages, and then here we are calculating the current instant power. Here we are calculating the difference between current and previous instant voltage, and here we are calculating the difference between the current instant and the previous instant power, and then here we are checking the condition of the P&O MPPT. So there are 4 conditions. First you have to check the dP is less than 0, and then we need to check the dV. So if dV is less than 0, we need to increment the voltage, otherwise we need to decrement the voltage. If dV is greater than 0, then we have to check the dV again. So dV is less than 0, we need to decrement the voltage, or else we need to increment the voltage. If dV equal to 0, we need to keep that V reference equal to previous instant voltage, reference voltage. After calculating this reference voltage, we need to compare that reference voltage with the maximum minimum limit. So within this limit, V reference is within the limit, no problem. That value will be taken for the further process. Otherwise, if it is maximum, and that means more than that V reference max or less than that V reference minimum, then we need to keep that V reference equal to V reference volt, and after that we need to override that V reference volt with the V reference, V volt with the V, and P volt equal to P. This code is keep on executing for every instant to calculate that V reference, and then with that V reference will be further used to control the boost converter. So here V reference is compared with the PV voltage, and it when we process via PI controller. So this will be act as a voltage controller, and it will be generate the duty cycle. That will be compare with the triangular wave, and then it will be generate the PWL impulse. This PWL impulse will be control this boost converter IGBT to extract the maximum power as well as to boost the voltage from 258 to 400 volt. So this is the first stage of conversion in the grid connected PV system. So next stage is 5 level inverter. Here you have the 5 level inverter. So this 5 level inverter is connected output of the boost converter and connected to the output, that means filter side, LCL filter. This is known as hybrid multi-level inverter with the reduced number of switches. So here we are using only 5 IGBT to generate the 5 level output. So this will be known as a bidirectional switch, so it will be operating both direction. And this IGBT will be controlled by means of this control logic. Here we create that switching pulse and control logic for that 5 level multi-level inverter. According with that controlling modulating signal from the control system, then it will be generate the pulse for S1, S2, S3, S4, S5. So that pulse will be used to control this multi-level inverter switches. How that pulses will be generated? For that we need a control signal. This control signal. So here we are measuring the reference voltage. It is going to be compared with the 400 volt, and then it going to be processed via PA controller, and then it going to be multiplied with the cos omega t. So cos omega t will be generated by means of PLL. Here we are using PLL. In order to create that cos omega t, we need to get the grid voltage. That means this is a grid voltage, and then we need to convert it into V alpha and then V beta. V grid equal to V beta, and V grid will be processed via 2 low pass filter, and then it will be known as a V alpha, and then after that you have to use that PLL loop, and then finally you will get omega t here. So this is omega t, and then when you have to process your cos and sin block, you will get the cos omega t and sin omega t. Now we are having the cos omega t here. So just you have to multiply it with this output of PI controller, because this is a voltage controller. It will be generate the reference current in the magnitude only. So we need to convert it into sinusoidal form. For that we need to multiply it with the cos omega t. Now we are getting the I reference in the cos cosine form. Next we need to measure the inverter current, and inverter current will be compared with this I reference, and then it going to be processed via PR controller. So now the PR controller will be generate the control signal, and it will be added with the grid voltage and then divide with the VDC, and finally we are getting a reference voltage. These two block will be act as a voltage and current controller for generating the control signal to control this 5 level multi-level inverter. So here we are getting a V reference. V reference will be processed here. We are comparing with the different levels. 2 level in the positive side and 2 level in the negative side. Another level is 0 level. Totally we will get to 5 levels. So finally here we are getting the switching pulse. The switching pulse will be used to control this multi-level inverter, and it will be convert DC to AC in the 5 level form. And here we are using that LCL filter to filter out that harmonic in the voltage, and then finally it will be linked with the grid, connected with the grid system. This is overall system, and then here we are measuring the PV voltage, current and power, and here we are measuring the grid voltage, current and DC voltage, and here we are measuring the inverter output voltage. Now I am going to simulate this model. Before simulation, here we are fixing the condition from 0 to 0.5, the irradiation will be maintained at 1000 watts per meter square. From 0.5 to 2, the irradiation will be changed from 1000 to 100. From 2 to 3.5, that irradiation will be changed from 100 to 1000 watts per meter square, and then we need to check the results. So for that I am going to simulate this model. Here you see that this is a PV voltage and this is a PV current. PV voltage maintained around 258 volt and current is maintained around 8 amps. And then here you see that is a PV power is comes around 2.1 kilowatt. And here so this is a DC link voltage. The DC link voltage maintained at around 400 volt. This is a grid voltage, and then this is a grid current. And here you will see that this is a multi-level inverter output voltage. So here you see that we will get the 5 level output, level 1, level 2, level 3, level 4 and level 5. So this is 0 level, so level 1 VDC by 2, and this is VDC. So this is minus VDC by 2, and this is minus VDC. Totally we are getting 5 level. Here you can see that another thing, here we are taking the current of the inverter and grid voltage, and then we have to compare that we are combining mixed ones. Here you see that voltage and current both are in phase. So here the power is injecting into the grid when that phase angle will be both are in phase. So that indicate that it have the unity power factor and also inject into that grid point. So here you see that power is already told from 0 to 0.5, the irradiation is 1000 watts per meter square, and from 0.5 to 2 seconds it changed from 1000 to 100 watts per meter square. As per that change in irradiation, the power is varying. After 2 seconds again it will be changed from 100 watts per meter square to 1000 up to 3.5. As per this logic, the grid current is reducing and the injection of power into the grid also reduced. After 2 seconds again that power generation is increasing. So here also you see that the current of the grid also increasing. Once you zoom this portions, you will see that current variation, and you can see the power here. The power, you see that the power of grid side is keep on decreasing in this point. After this point again it will be increasing, and we can check the level. The level is maintained at the 5 level always without any deviations. So now we stop the simulation. Next we need to check the THT. Now to check the THT, go to out and then take scope data 1 and enter. Next comes to here and then click tools and click FFT analysis, and then you select second input, and then here you go to type 1 second and 50 Hz maximum, same as maximum frequency, and compute FFT. Here you see the trend, we are getting almost 3.1%, 3.01% for the grid current. THT is also within that IEEE power quality standard. This is working up the grid connected PV system with 5 level multi-level inverter. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.